Welcome back to the Sustainable Design Lab podcast brought to you by Veritiv. In this podcast, we explore the big ideas that are reshaping the future of packaging. My name is Chris Bradley, and I lead the Sustainable Design Lab for Veritiv. This episode is part 4 in our EPR for Packaging Masterclass series. We are assuming you have listened to the previous episodes in this series, as the content in this episode builds on the progressive knowledge you will gain by listening to this series in order. Please note that the information we share on this podcast is not legal advice and should be only used as an overview of the regulatory landscape surrounding packaging. Each company's situation involves variables that determine how these regulations apply, and you should consult your legal counsel regarding how specific regulations impact your business. Please also note that when we refer to sustainable packaging or products, we mean that generally the packaging or the product is considered to produce less harmful impacts to human health and the environment than other options, or has an attribute such as being recyclable or compostable that is generally considered to be less harmful to human health and the environment than packaging without these attributes. Whether a product is sustainable may mean different things depending on what objective is trying to be achieved. All right, let's dive in. In this episode, we're going to discuss advanced packaging redesign strategies for EPR. This is the fun stuff. As we've discussed in previous episodes, EPR regulations have been designed to drive behavior change. If you understand the laws and employ smart design strategies, you may be able to lower your cost burden and create a strategic advantage for your company. We're now going to review 8 design strategies that you can use to redesign your packaging for lower fees under EPR. Design strategy number 1, targeted lightweighting. This first strategy might seem obvious, and it is, but it's important to emphasize because every EPR program bases its fee schedules on weight. Simply put, one of the easiest and most effective ways to lower your EPR costs is to reduce the amount of material that you use. Lightweighting has always been a classic cost-saving move, and under EPR, it becomes even more powerful. When you reduce packaging weight, you're not just saving on materials, you're usually lowering shipping costs or logistics costs as well. However, under EPR, we need to think about lightweighting a bit differently. It's not just about reducing weight across the board, it's about targeting those materials that cost you the most. Here's how we approach it. First, we analyze the total potential EPR piece for a business or product line, looking at both the cost per pound and the total weight by material category. Then we create a simple Pareto analysis, sorting materials by their total contribution to fees, which is weight times rate. And once you do this, the biggest opportunities for cost reduction will become clear. For example, if you're shipping a large volume of flexible multi-layer plastics, which range from 70 cents to $1.40 per pound in Oregon fees, even small reductions in film thickness or overall dimensions can generate significant fee savings. Can you reduce the package dimensions? Can you reduce the number of layers? Or even change to a different combination of layers to lightweight the overall package? If your design uses heavy rigid plastics, switching to thinner walled versions or more efficient shapes can also dramatically cut both weight and cost. In some cases, corrugated still may be your largest contributor to total fees, even though it has a relatively low rate per pound. This would lead you to look for ways to reduce box sizes, or even consider a box-on-demand type of solution to reduce your total tonnage. The key takeaway: don't lightweight randomly. Focus first on the materials that are contributing the most to your estimated EPR fees, and by targeting your efforts, you'll drive a much bigger impact both on your EPR bill and on your bottom line. Okay, design strategy number 2, which is what we call material shifting. If you study the EPR fee schedules closely, you'll notice something striking. There's a massive spread in material costs. Corrugated and paper-based solutions typically cost around 3 cents per pound under EPR programs. Meanwhile, plastics can cost 15 to 50 times more, often hovering between 30 cents and $1.50 per pound. This gap is going to drive a massive shift toward paper-based packaging. Historically, paper packaging has been significantly more expensive than plastic packaging for applications like void fill, trays, corner protection, and bags. But EPR really does change the game, and suddenly paper alternatives often come out cheaper when you factor in the EPR compliance costs. So here's a simple test that you can apply. Take any packaging line item in your bill of materials, add up the expected EPR fees, and divide that by the cost of that actual packaging. If the expected EPR fees are 30% or more of the packaging cost, you should seriously consider shifting to a lower cost material to offset those fees. I'll give you a real-world example. Imagine you're using 4 expanded polystyrene or EPS foam corners to ship a product such as a mirror or a picture frame. Each corner costs about 25 cents or $1 for the full set. The combined weight of all 4 corners is around a quarter pound. And the EPR fee ranges for EPS in Oregon or $1.94 to $2.58 a pound. So let's just use the low end of the fee schedule. We'll take the $1.94 times a quarter pound, and that means that you would have 49 cents in EPR fees for those 4 EPS foam corners. That means that the fees could add an extra 49% on top of your material cost. In this case, it would make a lot of sense to explore switching to molded pulp or corrugated fiberboard corners, which are highly recyclable, classified under the paper stream, and subject to much lower fees. Of course, you'll need to validate performance, ensuring that the paper alternative passes drop tests and protects the product effectively. But the potential cost savings plus sustainability benefits could be significant. Here's some other examples. Plastic mailer bags could be replaced with paper-based mailers, avoiding high EPR fees on flexible plastics. Plastic trays could be swapped for corrugated inserts or molded fiber trays for things like electronics, cosmetics, or appliance packaging. So the key takeaway from this design strategy: material shifting is about smart economics. EPR has upended many of the old assumptions built into your cost structures. If you're not reevaluating your material choices with EPR fees in mind, you could be leaving serious money on the table. And this leads us to design strategy number 3, which is closely related but a little bit different, and we call this category anchoring. Now, here is a question from one of the Circular Action Alliance's producer FAQs that was listed on the circularaction.org website. And here's what it says. If a package consists of multiple materials, for example, an aluminum aerosol can with a plastic cap, should they be reported separately or together? And here's how CAA, or the Circular Action Alliance, answered. This depends on if they are separable or non-separable. Separable components are those that can be removed from the main packaging by the end user, either after opening or after the product is consumed. All separable components should be reported separately in the appropriate material category that best fits their material type and form. Non-separable components are designed to remain attached to the packaging after the product is consumed and discarded. If a component, like a cap or lid, is intended to stay with the package when discarded, or there are on-pack instructions directing the consumer to replace the cap prior to disposal, then it is considered a non-separable component for reporting purposes. Non-separable components should be reported in the category representing the material type that makes up the majority of the combined weight. So this is a key insight. Building on this concept is a design strategy that we call category anchoring. Designing your packaging so that the majority of the weight falls into a highly recyclable, lower cost material category recognized on the state's USCL or MRL lists Under the Circular Action Alliance reporting rules, when packaging components aren't easily separable, the dominant material determines your EPR fee category. And so by anchoring your design to a material that is both broadly recyclable and cost-effective, you can significantly reduce your EPR costs through intentional redesign. Let me give you an example. Consider a product packaged in a flexible, multi-layer plastic pouch, a format that's not currently recyclable and thus incurs very high EPR fees in Oregon, typically 54 cents to 72 cents per pound. Now imagine redesigning that package into a paper-based pouch that may still include a thin plastic layer for sealing or barrier protection. If this redesigned paper pouch passes a repulpability test, such as those from Western Michigan University or the Fiberbox Association, proving that it can be easily recycled as paper, then it can be reclassified as other paper packaging. That classification can drop the EPR fee as low as 3 cents per pound, a dramatic savings driven by smart redesign. Here's another example. Consider a clear PET water bottle with a polypropylene cap and on-pack instructions to empty and replace the cap after use. Although the polypropylene cap alone would typically be assessed at 48 cents to 55 cents per pound under Oregon's fee schedule, the entire package is evaluated as a single unit. Because the cap stays attached and the PET makes up the majority of the weight, the full package is classified under the PET rate of 17 cents to 23 cents per pound. This integrated classification reduces EPR fees for the cap by nearly 50% compared to reporting those materials separately. So you can see now how you can, again, use the way that these EPR regulations and fee schedules are designed to make smart design choices. Let's now look at design strategy number 4, add PCR content. So another powerful lever to reduce your EPR costs is to increase the amount of post-consumer recycled, or PCR content, in your packaging materials. Both Oregon and Colorado have built eco-modulation incentives directly into their EPR programs to reward the use of PCR. Now, Oregon has outlined a pathway for gaining an eco-modulation for adding PCR through its Bonus B program, where an LCA is used to show the impact of adding PCR to a package. Producers will be eligible to apply for Bonus B in 2026, with the bonus available as a fee reduction on their 2027 bill. CAA will provide more details about how to apply for Oregon's Bonus B soon, but they have indicated that the Bonus B adjustment will start at a 20% reduction of Oregon base fees. So this is a significant opportunity for some producers. Colorado has also outlined a pathway to gain an eco-modulation for adding PCR at a rate that exceeds Colorado's 2030 target per material category. They plan to publish details about how this will work and how to apply for the bonus by October 31st, 2025. Like Oregon, these Colorado bonuses will begin in 2026 and will be available as a dues or fees reduction on a producer's 2027 bill. Here's how to approach it. Look across your packaging portfolio and identify where you can transition from virgin materials to PCR materials, especially in plastics, paperboard, and metals, where recycled content is now becoming more available and affordable. Focus first on high weight, high cost categories, places where a small percentage change in PCR content can deliver the biggest fee reduction. So here's the key takeaway. Adding PCR content isn't just about checking a circularity box anymore. It's a direct pathway to lower your EPR costs in the future. This all now leads us to our next design strategy, number 5, simplify multi-material structures. One of the smartest ways to lower your EPR costs is to simplify your multi-material packaging designs. Under EPR rules, Multi-material structures like laminated foil pouches, blister packs, or plastic paper hybrids are often classified as non-recyclable or hard to recycle, and as a result, they get hit with some of the highest fees. Why? Because separating different materials at the recycling facility is extremely difficult and often not possible at all. The solution is to redesign packaging to use monomaterial structures, meaning the entire package is made primarily of one material type, so it can easily flow through recycling systems and qualify for lower fee categories. Let me give you an example. Suppose you're packaging snacks in a foil-lined plastic pouch. Even if the outside looks recyclable, the inner foil layer contaminates the recycling stream, pushing it into a non-recyclable category. With fees in Oregon ranging from $1.07 to $1.43 a pound. By switching to a monomaterial polyethylene pouch using barrier coatings instead of laminated foil, the package can now be classified under monomaterial flexibles, cutting the Oregon EPR fee rates by 50% to just 54 cents to 72 cents a pound, while improving the potential recyclability at the same time. Another example, blister packs commonly used for pills or within electronics, made from rigid PVC and aluminum, are very difficult to recycle. If you redesign them into PET-only blisters with a paperboard backing, you can simultaneously make them easier to recycle and shift fee rates into a lower cost material class. So here's the key takeaway with this design strategy. The more that you can simplify the material structure and stick to a single dominant material, the lower your EPR fees and the more recyclable your packaging becomes. Simple structures are cheaper to manage, easier to recycle, and better for your bottom line. Okay, let's look at design strategy number 6, which is reduce problematic features. Another way to lower your EPR costs is to eliminate or redesign problematic features that make recycling difficult or impossible to the process. Many EPR programs, including Oregon and Colorado, are introducing eco-modulation penalties, extra fees for packaging that disrupts recycling streams. Common problematic features include things like metallic inks, carbon black plastics, PVC components, heavy adhesive use, and opaque or non-sortable materials. Even small design choices can push a package into a higher fee category if they create sorting challenges or contaminate otherwise clean material streams. So let me give you a real-world example. Let's say you have a clear PET bottle, highly recyclable, and a low fee. If you add a full-body shrink sleeve made from a non-PET material, that bottle can no longer be easily identified and sorted at a material recovery facility or MRF. The result, it may now be treated as a contaminant, pushing your fees much higher. Similarly, packaging printed with metallic inks or covered in non-removable labels can downgrade the quality of recycled materials, triggering malices in EPR fee schedules. Here are a few other examples. Carbon black plastic trays, often used for frozen meals, can't be detected by optical sorters, making them essentially unrecyclable. Switching to natural or detectable pigments keeps them in the recycling stream. Foil accents on paper packaging can contaminate fiber streams. Switching to simple water-based inks can often avoid this penalty. And then multi-layer adhesive between laminates can prevent recycling. So using peelable adhesives or minimal bonding can preserve recyclability. By removing these features that complicate recycling, you can not only avoid extra fees, but also boost the overall recoverability of your packaging, making it both more sustainable and less expensive under EPR. Okay, let's look at design strategy number 7, shifting from flexible plastics to paper flexibles. One of the biggest opportunities to reduce your EPR fees is to shift away from flexible plastic packaging, especially complex multi-layer films, and move towards paper-based flexible alternatives. Flexible plastics are consistently among the highest cost categories under EPR programs like Oregon and Colorado. Not only are they expensive, with fees often between 50 cents and $1.40 per pound, but they're also challenging to recycle, often falling into non-collectible or non-recyclable categories that trigger even higher fees or penalties. Paper-based flexibles, on the other hand, are typically classified under widely recyclable categories like corrugated or mixed paper. In most cases, the EPR fees for paper is just 3 cents to 8 cents per pound, a dramatic reduction compared to plastics. So here's how to approach it. Look for applications where you can replace flexible plastic pouches, mailers, wraps, and bags with fiber-based alternatives that are designed for recyclability. Focus especially on low barrier products where moisture and oxygen barriers are not critical. These are the easiest to convert over to paper. Here are some real-world examples for you to consider. Take a typical stand-up pouch for snacks or dry goods, often made with multi-layer films combining PET, polyethylene, and metallized foils. Under Oregon's EPR fee schedule, these packages are considered flexible plastics and could cost up to $1.43 per pound. By redesigning the pouch into a paper or cellophane structure, possibly with a thin barrier coating, you could shift the package classification into the paper stream and just pay 3 cents to 8 cents per pound instead. That's a potential 95% reduction in EPR fees. Plus, you improve consumer perception by offering a more sustainable, curbside recyclable option. Here's some other examples. Plastic poly mailers for e-commerce shipping can be replaced with padded craft paper mailers that are easily recycled with mixed paper. Plastic bread bags can be replaced with paper bakery bags with thin barrier coatings or cellophane that still meet recyclability standards. And plastic overwraps on multi-packs, so like on bottled water, can be replaced with corrugated cartons or fiber-based wraps. So here's some important considerations. Barrier performance matters. Not every product can immediately shift over to paper. Food products needing high moisture, oxygen, or grease barriers will require special coatings or hybrid designs. Certification can help, so look for packaging options that are certified recyclable by standards like How to Recycle, widely recyclable logos, or meet state recyclability definitions. All right, here's your key takeaway with this design strategy. Shifting towards recyclable paper-based flexibles is one of the most powerful moves you can make to reduce compliance costs while strengthening your brand's environmental story. There is a lot of innovation right now in paper coatings that are making this all possible, and we are happy to help you assess the options available if you're interested in exploring this particular opportunity. Okay, this leads us to design strategy number 8, design for easy disassembly. Another smart way to lower your EPR costs is to design packaging so that components can be easily separated by consumers before disposal. Under most EPR programs, including Oregon and Colorado, separable components are treated differently than non-separable ones. If two materials can be separated easily by hand without tools, they can be reported and recycled individually in their proper material streams. This can dramatically lower your fees by preventing a recyclable item from being dumped into a higher cost, hard to recycle category. If components stay attached and can't be separated, then the combined material is usually reported under the dominant material type, and if the combination makes it unrecyclable, your fees could jump significantly. So here's how to approach it. Design packaging with clear disassembly points, such as easy peel labels, pop-off lids, or separable layers, and provide simple consumer instructions on the pack that encourage separation before disposal. Here's a real-world example. Seventh Generation has developed an innovative laundry detergent bottle that's designed with EPR in mind. The package consists of two parts: a sturdy molded fiber outer shell and a super thin PET plastic inner bottle. The fiber shell provides structure and protection, while the lightweight PET bottle holds the detergent. After use, the consumer can easily peel the shell away from the bottle, allowing each component to be recycled separately. It's a smart, eco-conscious design that meets performance needs while lowering compliance costs. Under Oregon's EPR program, a traditional HDPE or high-density polyethylene detergent bottle could cost the brand about 12 cents in fees. This redesigned hybrid bottle brings that cost down to just 3 cents, saving 9 cents per unit through intentional sustainable design. Here's another example: a rigid PET container with a full shrink sleeve made of a different plastic. If the sleeve is perforated for easy tearing, it allows the consumer to separate the two materials, keeping the PET container in the high-value recyclable stream. Now, here are some important considerations. You got to make it intuitive. Don't rely only on labeling. Design disassembly points that are obvious and easy to use, and use simple callouts. Quick instructions like remove sleeve before recycling can boost compliance and recovery rates. You also want to avoid complex separation. If it requires tools or too much effort, it won't happen at scale. And so here is the key takeaway. Easy disassembly makes recycling easier and fees lower. The simpler you make it for consumers to separate components, the more recyclable your packaging becomes, and the more you can lower your potential fees. Okay, that wraps up part 4 of our EPR for Packaging Masterclass series. As we've discussed in this episode, EPR isn't just a regulatory hurdle. It's a catalyst for innovation that leads to smarter, more sustainable packaging design. By using these 8 design strategies that we've outlined today, or other strategies we haven't covered, companies can turn compliance into competitive advantage, reducing costs while improving environmental performance. The path forward isn't always easy, but it's full of opportunities for those who lean in. If you'd like help analyzing your packaging portfolio or exploring material shifts and redesign opportunities, Veritiv and the Sustainable Design Lab are here to support you. Thanks for listening, and join us in future episodes as we explore the cutting edge of sustainable packaging, from EPR implementation to compostable materials, AI-powered design tools, and other game-changing innovations that's shaping what's next.